everybody, in this video we're going to be talking about scientific notation. So scientific notation is used whenever you want to represent a really big number or a really small number. So it's very commonly used in things like astronomy, where you're talking about stars that are billions of miles away. It's also used a lot in like things like chemistry, where you're talking about atoms that are like super tiny compared to our units of measurements like grams. So the way that scientific notation works is you basically take the first digit in your number and you figure out what place value it's in. So in this case, the 5 is in the 10 billions place value, and 10 billion is basically a 1 followed with 10 zeros. Because if you look at the number of place values that come after the 5, there's 10 place values that come after that. And so the way we write this in scientific notation is we write it as 5 times 10 to the 10th power. But we still want to keep the 4 billion and the 100 million as well. And so the way we write that is we just write it as 5.41 10 billions. And so basically this is giving us the preciseness of the digits. And then this is telling us what place value that number is in. So we can also do this for small numbers. So if we had 0.00000023, the way we would write this in scientific notation is we would do 2.3 times the place value that the 2 is in. So if we look at what place value that is, we have the tenths, the hundredths, the thousandths, the 10,000ths, the 100,000ths, and the millionths. And so basically we'd have 2.3 times 1 over a million, and a million would have 6 zeros. So we could write this as 10 to the 6th power because 1 million has 6 zeros in it. Or another way that it's actually more commonly written is 2.3 times 10 to the negative 6. Because negative exponents create reciprocals. So this would be the scientific notation for this number. And when you're teaching this to students, you can introduce it as the number of spaces that the decimal moved. So for example, this decimal moved 1, 2, 3, 4, 5, 6 spaces. And this decimal moved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. And so that's where that exponent came from. And just remember that a positive exponent means that you're multiplying by 10 a certain number of times. A negative exponent means you're dividing by 10 a certain number of times. And so it will make the number smaller. So when you're working in scientific notation and you're trying to add numbers together, it's actually not very easy unless the place values are the same. So in a situation like this, where the place values are different, the process that you would go through is you basically convert them into regular numbers, add them together, and then convert them back into scientific notation. So like 5.2, if you multiply it by 10 3 times, your decimal point is going to move over 3 times, and you'll have 5,200. And then if you want to add this to 9.6 times 10 5 times, well, that's going to be 9,60000 because I'm moving the decimal over 5 times since I'm multiplying by 10 5 times. And when I add those numbers together, I get 965,200. And in scientific notation, that would be 9.652 times 10 to the 5th, because I have 9.6 hundred thousands. And so this would be the scientific notation answer for adding these two numbers together. And depending on what the place values are, your answers could vary quite significantly. However, if you do happen to have the same place values, like if they were both 10 to the 3rd, then you can just either add or subtract the numbers directly. Because if you had 5.2 thousands plus 9.6 thousands, well, you could just add those two numbers together, and that would give you the number of thousands you would have. But if you have different place values, then the easiest way is just to convert them into regular numbers and add them together. However, multiplying in scientific notation is much easier. Because if you're multiplying two numbers in scientific notation, you can use the commutative properties of multiplication to rearrange the problem. So you can think about this as 1.2 times 3.85 times 10 to the 6th times 10 to the 8th. And 1.2 times 3.85, when I calculate that out in my calculator, I get 4.62 times 10 to the 6th times 10 to the 8th. Well, if I have 6 tens multiplied together and 8 tens multiplied together, and those two things are multiplied, well, the total number of tens that are all multiplied together is 14. And so these two scientific notation numbers multiplied together would equal 4.62 times 10 to the 14th. And when you're dividing numbers in scientific notation, the process is very similar. Because if I do 1.2 divided by 6.25, let's see what my calculator gives me there. It looks like I end up with 0.192. And then if I do 10 to the 12th divided by 10 to the 8th, well, if I have 10 times 10 times 10, like 12 times, and that's divided by 10 times 10, 8 times, well, 8 of those are going to cancel out, and I'll be left with 10 to the 4th. So you might have noticed on the last slide, we added the exponents together, but when you divide, the tens are going to cancel each other out, so you subtract the exponents. Now, this is not technically in scientific notation, because in scientific notation, you're supposed to have one digit before the decimal point. So to convert this into scientific notation, I'm going to move the decimal over once by multiplying by 10, and that would give me 1.92. But if I multiply by 10, that's changing the number. So I'm going to divide this one by 10 to keep the entire number balanced. So I'm going to multiply the first number by 10 and divide the second one by 10 so that I keep it equivalent. And so 1.92 times 10 to the 3rd would be equivalent to this number that I got here. And this would be in scientific notation because there's one digit before the decimal point. And you can also use the same process if you have multiple digits before the decimal point. Like, for example, if you got an answer like 46.3 times 10 squared or something like that, well, you could divide this by 10 and multiply this by 10 to give you 4.63 times 10 to the 3rd. Because this would be in scientific notation, but this one would not because you have two digits before the decimal point. So that's how you work with scientific notation. If you have any questions, let me know, and I hope you guys have a great day.